In this tutorial, we learn how to use SOHCAH TOA to find unknown side lengths inside right-angled triangles. Remember, when we write SO, CA, and TOA, we should read those as follows. SO tells us that the sine of an angle equals to its opposite side length divided by the hypotenuse. CA tells us that the cosine of an angle equals to its adjacent side length divided by the hypotenuse. And finally, TOA tells us that the tan of an angle equals to its opposite side length divided by its adjacent side length. Now that that's said, let's see how to find each of the unknown side lengths marked with an X in each of these triangles. We'll start with this first triangle here. The first thing we should always do is summarize the information that we're given in the triangle. Looking at this triangle here, we can see that we're given an interior angle, which is 28 degrees, and that we're given this right-angled triangle's hypotenuse, which is 9, and I'll mark that with a capital H. And last but not least, the unknown side length X that we're looking for is opposite the 28-degree angle that we're given, so I'll write that with capital O. Now that that's done, we look through SO, CA, and TOA to find the only one of these three words which contains both the letters O and H. Looking through these, it doesn't take us long to see that the only one with both O and H is SO. That's the first one here. So to find the unknown side length X, we need to use the sine of the angle 28. And here's how we would do that. We write sine of 28 equals to the opposite over the hypotenuse. Now replacing both O by X and H by 9 leads to sine of 28 equals to X over 9. Now, on the right-hand side of the equation, we can see that X is being divided by 9. So to get rid of that 9, we need to multiply the right-hand side of the equation by 9. But since we're doing that on the right-hand side, we must do that on the left-hand side as well. So that becomes 9 times sine of 28 equals to X, which is being divided by 9 and multiplied by 9. And since those two operations cancel each other out, the right-hand side simply becomes X. And we can write this in the opposite order to say that X is equal to 9 times sine of 28. And at this stage, we're pretty much done. All we have to do now is use our calculators to calculate 9 times sine of 28. And in doing so and rounding to 2 decimal places, we find that X is equal to 4.23. And that's our final answer. We now move on to the second example. And once again, our first step is to summarize the information we have inside the triangle. Looking at this, we can see that we're given an interior angle 50 degrees, and relative to that interior angle, we're also given its adjacent side, which is 4, and I'll mark that with capital A. And the side length we're looking for, that's the X we have here, is opposite to the 50-degree angle. So I mark that with a capital O. Now that that's done, I look through SO, CAH, TOA again for the only one of the three which has both the letters O and A inside of it. Looking at these, it doesn't take us too long to see that the only one with O and A in it is TOA, which tells us that tan of 50 must equal to its opposite side length divided by its adjacent. In other words, we can now write tan of 50 equals to opposite over adjacent, and now replacing O by X and A by 4, that becomes tan of 50 equals to X over 4. We can see now that on the right-hand side, the unknown X is being divided by 4. So to get rid of that 4, we need to multiply the right-hand side by 4. And as always, anything we do on one side of the equation, we must do on the other. So we multiply the left-hand side by 4 as well. And that leads to 4 times tan of 50 equals to X divided by 4 times 4. Since those two operations cancel each other out, that leaves us with X. And we can rewrite that from right to left as X equals to 4 times tan of 50. And now that we have this expression for X, all we need to do is use our calculators to calculate 4 times tan of 50. And in doing so and rounding to 2 decimal places, we find that X is equal to 4.77. And that's our final answer. Finally, we work through the third example we have here. And once more, our first step is to summarize the information that we're given. we can see that we're given an interior angle, which is 62 degrees, and that we're also given the hypotenuse of this right angle triangle, which is 11, and that I mark with a capital H. And the unknown side length x is adjacent to the angle that we're given, so I mark that with a capital A. All we have to do now is look through the three words SOH CAH TOA for the only one which has the letters A and H inside of it. Looking at these three words, it doesn't take us too long to see that the only one is CAH, which tells us that the cosine of the angle 62 degrees must equal to the adjacent side length divided by the hypotenuse. In other words, we can go ahead and write cosine of 62 equals to adjacent over hypotenuse. Replacing A by x and h by 11 leads to cosine of 62 equals to x over 11. Now on the right hand side we can see that the unknown x is being divided by 11. So to get rid of that 11 we multiply the right hand side by 11. But as always we must do the same on the left hand side. So I multiply that by 11 as well. And that leads to 11 times cosine of 62 equals to x divided by 11 times 11, which is just x. And I can rewrite this from right to left, which would be x equals to 11 times cosine of 62. And at this stage, we have an expression for the unknown x. All we need to do now is use our calculators to calculate 11 times cosine of 62. Doing so and rounding our answer to 2 decimal places, we find that x equals to 5.16. And that's the final answer. And there we have it. That's the end of this first tutorial on SOHCAHTOA, in which we learn how to find unknown side lengths.